All right, guys, good morning. My name is Daniel Baker. I'm Program Manager for Plastics at Endeavor 3D. Today I'm going to talk to you about the HPMJF printing process, why we use additive, and then the full life cycle, so from prototype all the way through to production. So a quick agenda for the day. We'll go through an introduction, who Endeavor 3D is, why we use multi-jet fusion, what it is, and then how that process is used and the full life cycle of production for us. So quick introduction, Endeavor 3D, contract manufacturer based just outside of Atlanta, Georgia. We have a 65,000 square foot facility that we have transformed into an additive focused kind of center of excellence. We are a digital manufacturing partner with HP. We offer all of their services on the polymer side as well as the metal side. So what is multi-jet fusion? Multi-jet fusion is an end-to-end platform from the printer itself that makes your parts through to the software on the back end. So HP has a number of softwares that integrate into their platform that seamlessly help us through our production process. The part is uploaded digitally to the printer and then it's moved through to production. Quick overview of the process itself. Simplified in a 4-step process. You have powder that is deposited onto a print bed and then 2 different agents that are deposited onto that powder. So you have a fusing and a detailing agent. The fusing agent is what actually cures your part and forms that ultimate plastic part that you're used. Then energy is delivered. So heat is applied to the build. That part is cured, it's solidified, and then it goes through a repeat of that process. New powder is deposited over the top. The bed is dropped down in the Z. Parts are printed atop of that, and then you rinse and repeat several thousand times, and then ultimately your part is pulled or extracted from that powder. So let's talk materials. At Endeavor 3D, we offer kind of a wide range of their materials. All of the nylons, we have nylon 12 white, PA11, and their TPU. You can see here the build volume is relatively large for an additive system. It's about 15 inches by 15 inches by 12 inches in the Z, or 381, 284, 381 millimeters. If we look at these materials, the nylon 12 and the nylon 12 white are kind of workhorse materials. Those are your standard nylon plastics. They can go for a wide range of applications from housings to more structural components. They are all biocompatible, UL 94, and relatively strong isotropic parts are produced on that. The reusable nylon 11 is our sustainable material. So it is sourced through our partners at Arkema, and it is, again, biocompatible, it is reusable. And then we have the thermoplastic TPU for your rubber like. That's a Shore A88, and it gives you the ability to produce rubber-like parts outside of the rigid nylons that we are producing. For the full color system, it's a relatively new material launched about 1.5 years ago from HP. What this does is it opens up the full range of colors on the platform. Historically on the platform, your parts are kind of this darkish gray, which gives you the ability to have darker color parts, black, dark blues, dark reds. But with the addition of the nylon 12 white, it opens up that range to neon colors, yellows, pinks, greens, anything else that you can think of to produce. Available services with us at Endeavor, full life cycle for the production. So we do offer design and engineering services, reverse engineering, scanning your parts. So if you need a CAD file created, we will produce that. We have the metal printing and sintering as well. Polymer printing, as we've talked about. Post-processing dyeing, so that's full color, vapor smoothing, media removal, anything that you need to kind of surface finish your part, we can assist you with. Our quality assurance lab is pretty extensive. It's something we pride ourselves on at Endeavor, is our commitment to quality. With that, we have about 25 pieces of equipment today, and we're expanding that pretty rapidly. So tinsel testing, the powder testing on the front end, or any kind of post quality assurance you need on your part. And fulfillment and packaging on the back end. So if you need support there, either shipping direct or any other packaging solutions, we can help you provide that. So let's talk about why 3D printing, get into the meat of the presentation. We're going to talk about really kind of 4 aspects here where we use printing today for our customers. The first is bridge to tooling. It's one of our most common, where we're doing mid to low volume runs as a customer ramps through development. End of life and spare parts. That's another large market for us. So say you're in production today with an injection molding component, or you have a legacy component that you need additional parts for. What we do is we will help qualify that on an additive platform for the end of life of that production program or production part. The next is high volume production. So that's full scale, from start to finish, qualified production on an additive platform. Typically that comes in the form of DFAM. We will help you redesign your part, get it scaled for the platform, get those cost savers or the kind of economy of scale using additive by adding certain components or redesigning it for the MJF process. And then lastly, which is very common as well, which is just prototyping for the platform. We'll look at this curve here and we'll kind of talk through each step. So prototyping, everyone's familiar with on an additive platform. It's what it's been used for 30 years. It's quick part. You need a part today, cheap, plastic, quick. You can run anything through our system. So what the beauty of the MJF system being a powder bed is your design constraints aren't as limited as other platforms. We're not using a support material. It's not a liquid resin process. So you're not having to remove that or design certain features. You can actually take your injection mold design, put it into our platform, and just produce a prototype day one. The next is bridge production, as I mentioned. There are hundreds of examples. The Z clip here from HP is a great one, where they needed rapid development on a brand new product to market. So speed was the key. So rather than waiting 6 weeks for a tool, they started the process with additive while they were ramping, while they were getting customer feedback and understanding that process, and they were able to produce several hundred units very quickly, get to market, get that test feedback, make design revisions without having to pay for changes on a tool or wait for those parts to be shipped back to them. Full production, as I mentioned, there are a number of applications now for additive where full production has kind of seen life through a number of platforms. Specifically automotive, we are starting to see the rise of EVs and kind of lower volume, low run. I think connectors, interior trim pieces, any kind of part in a car where you're not running thousands day one. We have moved to additive platforms. We see it in aerospace, consumer goods. There are kind of endless applications as we start to qualify materials. They get stronger, the materials are getting cheaper, and the printing process is getting faster. It used to be, you could run a couple hundred parts a week. Now we're running, at rates in the thousands per week on certain components. Then, as we talked, end of life. Another great example there are legacy parts. We actually have a partner in Douglasville, Georgia, where we're located, where they had a legacy part that they did not have the actual CAD data for. They brought us that part. It's a housing for a light fixture. So we actually took the physical component, scanned it, rather than going back and retooling to be able to service their customers for this part that was about 15 years old. We converted that to digital CAD, and we run them on demand as needed for that customer. So we're producing 10 to 15 a week just to service their spare parts or their end-of-life inventory. And then lastly, we'll talk about jigs, fixtures, and tooling. It's also pretty common. Any kind of manufacturing aid. Additive is a great feature for that because you can design custom features or custom parts for specific manufacturing processes that are dialed for that system. So if you have a handle or a stop on a line and you need that to be more ergonomic for your user or the worker in your factory, we can design those pieces for each individual, and those are more custom, which speeds up the process or makes your process on the manufacturing line a little more efficient.